Hey guys, so today we're going to be graphing some more piecewise functions, and I'm just going to do a few with you. So if you have more questions, watch the video from yesterday, and I do a bunch of those. So the point at which our graph is going to move from one graph to the next graph this time is at -4. So I'm just going to highlight on the line on -4, and I know that I'm looking at one graph this way and then another graph this way. So the first graph that I'm going to be looking at is with 3. So that means that no matter whatever my x value is, my y value is 3. So remember, you need 2 points to make a line, so I'm going to pick like -8 and then -4. And then both of these answers are going to be 3. And then that's this cute little section here is this. And then I like to repeat again, so -4, because I need to know where the dots are on this line. And then I'm just going to pick some random numbers and kind of spread things out. So 0 looks like good, and then 4 and maybe 8. So just enough to where I can see my curve or my straight line. Since this is a linear equation, I know it's going to have a straight line. But anyways, you can make a table or you can just graph it if you remember to go up 3 and then put a dot. Your slope is +1, so you can go up 1 into the right one or down 1 into the left one. And then be careful on this line. Since there's no line underneath it, I need an open dot for this guy. And then this one, since there is a line, I need a closed dot. So I need a closed dot at +3. And then my guy goes this way. This is because I can only have one dot on a line at a time, or else it's not a function, and these are all functions because it says piecewise functions. So if there are 2 dots on one line, it means that it's not a function because it doesn't pass the vertical line test, and therefore we can't graph it. Anyways, so if you were like, wow, that was crazy how she did that. Again, this was from 8th grade, and we did it a little bit in 9th grade, but you can always use a table of values. You plug in your -4, so -4 plus 3 is -1, which is what I got, -4, -1. And then 0 plus 3 is 3, so 0, 3, which is again what I got. And then 4 plus 3 is 7, which is what I have. Wait, where are you? Yeah, 4, 7. And then 8 is off of the grid, because 8 plus 3 is 11. So anyways, my line looks like this guy, like that. So beautiful. Okay, and then just be careful when you're graphing 3. It splits 3 times, so we have a -3, shift or split. It's almost like you're cutting the graph and then gluing it, and sometimes the graph looks pretty, but a lot of the times it looks kind of like Frankenstein like this. So anyways, so we're gonna have 3 different graphs. We have this first guy is graphed here, and then this one is graphed here, and then this last piece is graphed over here. Okay, let's try another one. Okay, let's look at number 5. On number 5, oh, let me turn on the light. There we go. Oh, so much better. Okay, so number 5, x, y. I'm going to transition at that -3. Okay. And my first value is 6, so that means wherever x value I put down, my y value is going to be 6. So I'm just going to put down 2 numbers, so like -8, and then I want to put down my -3. And these are going to both be 6. And then I put down -3 again. And then this. Okay, so think about this. Can we take the square root of a negative number? No. We get I. And we can't graph I. It's not a thing. So, underneath our radicals, we don't want any negative numbers. So if I pick negative numbers, negative numbers times negative numbers are actually positive numbers. So negative numbers work really well. Well, I only have a few numbers between -3 and 0, so I'm just going to pick all of them. -3, -2, -1, 0. Now here's the problem. Once I put 1 in here, I have 1 times -2, which is imaginary. Oops. So this is not going to work. None of the positive numbers. So this graph is only going to go like here. And that's okay. It's totally fine. Okay, let's type it in. I like to use parentheses so that I'm telling the calculator exactly what to do. -2 times -3, and that is 2.45. Then we have, oh come on, -2 times -2, which is 2, and then times -1 is 1.41, and then times 0 is 0. Okay, so now we're going to graph. I want an open dot at my 3, so -3, 6. -3, 6 is an open dot, and then I have a closed dot here, and it goes this way. And now I have a closed dot at -3, and I get that it's a decimal. It's totally fine. I'm sorry. No, yeah, that's right. -3 and then 2.45. So 2.45, I don't know, here? That's a perfect spot. -2, 2, -1, 1.4. Yeah. You like how I rolled the pen? Okay, and then 0, 0. And then the rest doesn't work. So it's just this cute little curvy to right there. And that's okay. So that's what I wanted to tell you about radicals. Just be careful. If it's like this, you can't use any negative numbers. But this is all positive anyways, so that doesn't matter. And so does this one, uses all positive, and this one uses positive numbers. So anyways, just be really careful if you see a negative radical. You can't graph imaginary numbers. Let's do one more together. Yeah, because the rest are linear. I think you're okay with that. I want to do number 11. Now, if you don't remember exponents, exponents have exponential curves, which means they grow really quickly or they decrease really quickly. You have 4 different types of exponential curves. You have ones with like flat and then quickly. You have ones that go the other way, quickly, down, flat. You have one of these guys that's like this and then flat, or the opposite way, flat and then like that. That's, you know, never happy. Okay, anyways, these are the 4 types of exponentials that you have. These exponentials are usually 4 to the x, or some positive number to a power. And then, depending on where your negative number flips your picture, different ways. Yeah. Okay, so let's talk about 11. When you have an exponential equation, this extra number that's getting added or subtracted, and it has to be the extra one getting added or subtracted, shifts your graph up or down. So normally this equation, this asymptote, is on 0. But when you have an extra number, it's going to move your graph up or down, and it's going to shift your asymptote. So on 11, your asymptote is really at -2, which means your flat spot here. Okay? So I want numbers that are smaller than 3, which means that you probably won't see a lot of what it is. It just will be a kind of a flat line right by -2. So I'm going to pick, actually, it goes to +3. So yeah, you'll see the curvy part. Okay, let's pick -6, -4, -2, 0, 2, 3. Exponentials, you want to pick quite a few because you want to see the curve. And then I need a 3. Oh, and it's just 5, so pick another number. -5, I'm sorry. Alright, we're almost there. Okay, so now I'm just going to plug these guys in. We did this last year in secondary 1, and if you don't remember, that's fine. So it's 2 and then the x with a boxy button, so you can get an exponent, or your caret button, and then -2. And you're going to get a decimal, you want a decimal, of -1.98, which is really close to -2. And that's our asymptote. Okay, we're going to do this again, but with our 4, and we have -1.94. So we're getting a little bit bigger. Okay, and then 2, and that's -1.75. And then anything to the 0 power is 0, or 1, sorry, my bad. And then 1 minus 2 is -1. 2 to the second power is 4, minus 2 is 2. 2 to the third power is 8 minus 2 is 6. Okay. And then my dot, this guy should be open at 3. Oh, heavens. That marker. Okay. So negative 6 and then negative almost 2. There. Negative 4, again, almost 2. Negative 2 and a little bit higher. Not much. I mean, these boxes are kind of tiny. It's hard to see exactly where it would be. 0, negative 1. So here comes the curve. 2, 2. And then an open dot at 3, 6. So this is our exponential curve. This is our asymptote. It actually isn't ever crossing negative 2. It just kind of looks like it. I guess it doesn't need the arrow. I forgot what we were doing. My bad. Don't put the arrow. This is just part of my yellow line now. I'm so sorry. Heaven, should I not write in pen? We're also doing exponents in 9th grade right now, so that's not really helpful for me to help remember what we're doing in what class. Close dot, and it goes this way. Okay, this really only goes here, stops like that. And this is your graph. Okay, if you have any more questions, let me know. I hope you guys have a great day. I miss you all. Bye.